Okay, Assalamualaikum warahmatullahi wabarakatuh. Today, I wanna go to present about wireless transmission. But wireless transmission divide spread five broad topics. Okay, the first the first presents for what presents and discuss about wireless transmission by Fahmee Alee. Okay. Okay, the next topics electromagnetics discussed and present by Okay, the next topics is radio transmissions discussed and present by Sayutee. And the next topics microwave transmission discussed and present by Muhammad Binratis. And the next topics is infrared present discussed by Roiyan. Okay. Okay, the last topics light transmissions presents by Niabdulkuddus. Go ahead, Niabdulkuddus, to present and discuss about these topics. Thank you, Niabdulkuddus. Thank you, Niabdulkuddus, for discuss about this topic and makes more understand for with everyone. Thank you. And the last, I have to summarize a little bit about wireless transmission. Wireless transmission is use only signal, no landlines, and use only signal. You want to send or bring some file, use only signal and send to someone you want to send him. Okay, thank you everyone to watch our video about wireless transmission and brought two of them. Okay, thank you everyone. Assalamualaikum warahmatullahi wabarakatuh.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Fahmee Alee. Okay, today I want to discuss about wireless transmission. Okay, firstly, you should know our act have given right to information junkies. People will need to be online all the time. For this mobile user to be spare and fiber optic are of no use. They need to get their heat of data for their laptop, notebook, and shirt pocket. Some of our wristwatch computer without being to the retail communication infrastructure for this user. Wireless communication is the answer in the following section. We will look at wireless communication in a general. It has many other important applications besides providing connectivity to users who want to surf the web from the beach. Wireless have an advantage for even fixed device in some circumstances. For example, if running a fiber to a building is difficult to the terrain, mountain, jungle, swamp, wireless may be better. It is noteworthy the modern wireless digital communication began in the Hawaii Island, where large chunk of the Pacific Ocean separated the user from their computer center, and in the telephone system was inadequate.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And me will to explain the topic about the electromagnetic spectrum. And what is the electromagnetic spectrum? A spectrum of electromagnetic wave of varying wavelength. The visible spectrum is line. When white light passes through a prism, it is reflected into different colors, which each color the spectrum from the low to the high wavelength, respectively as follows: purple, indigo, blue, green, yellow, and red. When electrons move, they create electromagnetic waves that can propagate through space, even in the vacuum. The waves were predicted by the British physicist James Maxwell in 1865 and first observed by the German physicist Heinrich Hertz in 1887. The number of oscillations per second of a wave is called its frequency, and is measured in hertz in honor of Heinrich Hertz. The distance between two concentric maxima or minima is called the wavelength, which is universally designated by the Greek letter is lambda. When an antenna of the appropriate size is attached to an electrical circuit, the electromagnetic wave can be broadcast efficiently and received by a receiver some distance away. All wireless communication is based on this principle. In aviation, all electromagnetic waves travel at the same speed no matter what their frequency. This speed, usually called the speed of light, is accuracy measured 3 multiplied 10 power 8 meg per second, or about 1 foot per nanosecond. In copper the fiber, the speed slow to about 2 in 3 of this value and become slightly frequency dependent. The speed of light is the ultimate speed limit. No object or signal can ever move faster than it. A weather band is used with 3 variations. Okay, the first is series footnote. This technique was introduced by the Australian-born Grada Hedley Lama. Her first husband was an armament manufacturer who told her the easy is to block the radio signal and then use it to control the torpedo. A second form of spread spectrum. There is sequences spread spectrum use a code sequence to spread the data signal over a wider frequency band. It was widely used commercially as a separately apparent way to let multiple signals share the same frequency band. The signal can be given different codes. A method called CDMA or CDMA or code division multiple access. And then a third method of communication with a wider band is UWB, or called ultra wideband communication. UWB sends a series of repeat process wherein the position to communicate information. The repeat transition led to a signal that is very thinly over a very wide frequency band. UWB is defined as signal depth. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sayutee. Today we will explain radio transmission. Radio frequencies are waves are easy to generate, can travel long distance, and can penetrate buildings easily. So they are widely used for communication both indoor and outdoor. Radio waves also on this directional, meaning that they travel in all directions from the source. So the transmitter and receiver don't have to be carefully aligned now physically. The big properties as low frequencies radio waves pass thoughts of a trace wave, but the power fall off sharply with distance from the source, unless as fast as 1 or 2 in air. As the signal energy is spread more thickly over a larger surface, this attention is called path loss. In the VLF, LF, and MF band radio wave follow the ground as illustrated in fish. These waves can be detected for perhaps 1000 kilometers at the lower frequencies, less at the higher ones. AM radio broadcasting use the MF band, which is why the ground wave from Boston AM radio station cannot be heard easily in New York. Radio waves in this band pass through buildings easily, which is why portable radio works in the indoor. The main problem with using this band for data communication is the low bandwidth. Look at the future. Earth's surface. The surface in the VLF, LF, and MF band radio always follow the curvature of the Earth. Earth's surface belongs here. In the SF band, there's bands of inosphere bands. Okay. For today, just thank you so much to watching. Bye.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad. My supporting topic is microwave transmission. Okay, let's see. Okay, what is a microwave? It is a type of radio frequency that has a frequency between 0.3 gigahertz until 300 gigahertz. In most applications, the frequency between 1 gigahertz until 60 gigahertz, because it's the frequency that can be produced by electronic devices as a communication medium at higher speed in the gigahertz level. And because the wavelength is measured in micrometers, therefore called a microwave. The transmission of information by means of the microwave signals, which are electromagnetic signal, into the air along with the information that needs to be transmitted, and there must be a place to send or receive the information. And because the microwave signal travels in the straight line at eye level, cannot turn or curve along the edge of the Earth with a curvature. Therefore, there must be a station to receive and data periodically and transmit information to one another between a station to station until the destination station of the topography are mountains or tall building blocking the waves. It will not be able to send a signal to the target. Therefore, each station needs to be located at a higher place, such as a rooftop, a tall building, or a mountain peak to avoid collision. Due to the aforementioned linear travel of the signal, this is type transmission medium is suitable for the transmitted data in very remote areas. Okay, next.
Okay, Assalamualaikum warahmatullahi wabarakatuh. I got infrared transmission. What is infrared transmission? Infrared transmission refers to energy in region of electromagnetic radiation spectrum wavelength longer than those of visible light, but shorter than those of radio wave. Correspondingly, infrared frequencies are higher than those of microwave, but lower than those of visible light. Thermal imaging. What is thermal imaging? We can sense some infrared energy heat. Some objects are so hot they also emit visible light, such as a fire, dust, so on. Such as humans are not hot and only emit infrared waves. I cannot see this infrared wave, but instruments that can sense infrared energy, such as night vision goggles or infrared camera, allow us to see infrared wave emitting from warm objects.
From light transmission, guided optical signals or free space optics have been used for centuries. Paul Revere used binary optical signals from the old North Church before his expedition. A more modern application is to connect lamps into buildings using roof-mounted lasers. Laser signal transmission is unidirectional, so each end needs its own laser and its own optical director. This model has very high bandwidth at a low cost and is relatively safe. It is difficult to tap a narrow laser beam. Installation is also quite easy. Unlike microwave transmission, it doesn't require an FCC license. Wireless transmission. One of the authors, AST, had attended a meeting at a hotel in Europe. The meeting organizers have carefully prepared a room full of terminals to allow attendees to read email during boring presentation, as the local PTT didn't want to install a large number of telephone lines in just 3 days. The organizers placed a laser off the roof and aimed it at the side building, university computer a few kilometers away. The physical layer. By camera
illuminating and display emitting light using LED and other technologies. Data communication can be superimposed on this display by encoding the information in a way that the LED turn on and off. Thank you.